Simone. I'm Antonio Servetti from the Politecnico of Turin, and in the next 10 minutes I will present to you the dataset that we collected to measure the performance of DASH streaming from about 20,000 internet addresses around the world using our program that is called Neubot. And so I would like to thank particularly Simone Basso, that is the main developer behind Neubot. Okay, as we know, DASH, that stands for Dynamic Adaptive Streaming over HTTP, is a recent standard dated 2012 that is gaining broad adoption, both in the web scenario, let's say for example, the experimental performance platform of YouTube that use DASH for HTML5, and it is gaining adoption also in the broadcasting scenario. A recent survey from the European Broadcasting Union says that 85% of the broadcasters are going to introduce DASH in this year. So, first of all, a few words about DASH. It will be very short, since yesterday we had 7 out of 12 papers introducing DASH already. So basically, with DASH, we have the video that is split in several segments, and the segments are provided at different bit rates. Let's say the green, the low resolution, then higher quality, and then higher quality again. And periodically the client requests to the server a segment, let's say the low resolution, and when the download time is shorter than the video duration, then it means that he can ask for higher quality, and so he requests for higher quality, and so again. So the peculiarity of DASH is that is a client-centric approach. That is, it relies on the client for operational metrics, and this is particularly true for the adaptation problem. That is, how to choose the video bit rate among the available bit rate, the available representation, that maximize the quality, but also minimize the probability of rebuffers, that is, freezes during the playout. So in order to measure the streaming performance from the client point of view, we added a DASH test to our project, Neubot. And Neubot is a program that interested people can install in their computer. It runs in background, and it periodically performs some transmission tests. So we hope that making the measurement publicly available on the web and presenting in this session, we may help in a better understanding and simulation of DASH streaming. In the future, we plan to add some features, that is to offer a web API for querying the measurements, let's say to get the average bit rate of a given IP for a particular day. And we plan to implement and test different streaming adaptation logics, because this is the interesting thing about DASH. By the way, a few months ago, also Google announced that they are interested in measuring streaming performance of YouTube in particular, and to rate the ISP accordingly. And they called this project Video Quality Report. So, some details about the Neubot architecture. The program I mentioned before that people install in their computer is called the agent, and we have also some server components. There is a master server, the triangle, the red one, several test server, and an archive server. When a test is to be performed, the agent connects to the master server it is informed about the location of the test server, which one is active or not, and it is informed about the test to be performed. So the agent connects to a particular test server, it performs the test, and the results are saved on the test server. Only at the end of the day, all the results from the test servers are archived in the archive server. The test servers are part of the Measurement Lab, that is a platform partially funded by Google that has several servers around the world. Actually, there are 4 sites around the world, one in Singapore, also one in Turin, my place, and most of them in the United States and in Europe. Here is a map of them. So the Neubot DASH test acts like a DASH client. So for each video segment to be downloaded, we configured the test to use a limited set of video representation rates, the one that have been defined by the DASH dataset that has been presented here in 2012. So let's say we have rate 1, rate 2, and rate 3. The client selects a rate, and so the size of the next segment to be downloaded. He requests the segment to the server, and the server answers with the data, and it takes some time. We call it the elapsed time. The ratio between the segment size and the elapsed time tell us what we call the estimated available bit rate, that is the bandwidth of the connection at that time. So from this measure, the client may select another representation bit rate for the next segment, that is the maximum rate among the available one, that is lower than the estimated available bit rate. So for the next segment, we have another request and the response, and so on. After each segment, we adapt the bit rate to be requested to the server. Here are some of the data we save for each test. Every user is given a unique identifier, and we also save the IP address of the user, the IP address of the server, the time the test is performed, and the latency of the connection. Then, in the second half of this table, we save some data for each segment that is downloaded, and it's the video duration, here it's 2 seconds, the video bit rate, here is 5,000 kilobits, and then we measure the time of the download, we call elapsed time, and the number of bytes received that make possible to compute the available bit rate of the connection. Then the dataset is post-processed to add some additional information from the IP address. We get the location of the computer, the client, with the longitude and latitude coordinates, the country, the city, and also the autonomous system, that is the service provider the client belongs. In the last 3 months, that is the time span of the dataset we are making available, we had 2 million tests from 2,000 active users, from 5,000 locations around the world. Here is a map of the location, and we involved 30,000 IP addresses that belong to 1,000 autonomous systems, most of them from the United States and from Italy, and also from other countries. If you connect to our website, that is MediaPolito IT Neubot, probably I have the web page, okay? You can see up-to-date results about Neubot and all the statistics of the countries, the autonomous systems, and so on, that have been performed. And like Google, in its video quality report, we can also measure the performance of different internet service provider. Here are some histograms of the average bit rate of the DASH tests for 3 different providers in the United States, in Italy, and in Great Britain. And so we can see the bandwidth provided to the user for streaming. I like to say that Neubot runs for a given IP several tests per day. We have the IP numbers here and the time of day there. And you see that we have several tests for each IP because every IP runs a test every half an hour if they are connected. And 50% of the IP address run at more than 7 tests per day, with a mean of 360 tests per hour. In the paper, we also proposed how the bandwidth measurements can be used to drive simulation on the performance of different DASH adaptation logics. Okay, the next one. In fact, from the measurement, we can build a download profile because the trace file tells us that at a given moment, the client requested a segment of a given size, V, and the download took some time, E. And from the ratio, we can build a download profile with the time on the x-axis and the number of bytes on the y-axis. Okay, and from this trace, we can simulate the DASH download and the adaptation logic behavior. Because at a given time, the adaptation logic select a bit rate, so the size of the next segment to be downloaded. We can use the trace to estimate the download time for the segment. Okay. We can also simulate the playout buffer and, for example, see if some freezes occur when these 2 lines cross. And this is an example of the results we can compute. The red line with the points is the trace file, and the other lines are the simulation of the adaptation logic. Okay, we have simulated several adaptation logic. This is the bitrate selection for the segment, and this is the buffer occupancy. Okay, in conclusion, we hope that making publicly available this live data set, because it's a live system, every day a new tests are performed. With here is the plot of the DASH test, 10,000 tests per day. We can help in better understanding DASH streaming over the internet and foster the development and comparison of different adaptation logic. Okay, everybody is welcome to download the dataset. This is our URL, and also the conference, I hope, will provide an address, and thank you for your attention.
Thanks a lot. I think we have time for a quick question. I can shoot a quick question. What do you think we can learn, or what is the most important thing we can learn from your data?
Okay. The most important thing is to have real measurements that can take in account how the last mile behaves in case of streaming, the latency and the download rate. And most of all, we hope to be able to integrate in these systems some adaptation logic so that we can have real data about how adaptation logic behaves in the real world.
Okay. Thank you very much.
Can you add one station?
Excuse me?
We have a wireless module.
A wireless
Last mile.
module. Okay. The measurements are taken from the clients, let's say my laptop, everybody laptop. So we are taking measurement both from the wireless and wired network. It depends how you connect to the internet. And because we are concerned about, let's say, the last mile bandwidth, but we are also developing a mobile application so that you can install it on your smartphone and save the information about your wireless connection, the 3G and so on connection.
Okay, thank you again.
Thank you very much.